So for today, we're going to get the equivalent value of sine bt times u of t in the time function into the complex frequency function, which is equivalent to b over b squared plus s squared. So using the Laplace transform for us to get the complex frequency function equivalent of this sine bt in the time function, we're going to integrate, rather it is equal to the integration of e raised to negative st multiplied by sine bt dt. So you're wondering where the u of t gone. This u of t here is equivalent to 1, so we're going to remove that. So let's start. So as you can see, we have a Euler's identity and a trigonometric identity. So we're going to use the integration by parts. So our u is equivalent to sine bt, and the derivative of sine bt is equal to b cosine bt. Our dv is equivalent to the e raised to negative st dt. So for us to if we're going to integrate it, v will be equal to negative 1 over s times e raised to negative st. So the formula for the integration by parts is u v plus minus the integration of v du. So if we plug in those equivalent values, we would come up with this equation, which is the negative e raised to negative st times sine bt over s approaching from 0 to infinity, so don't forget your limits, plus b over s times the integration of e raised to negative st cosine bt dt approaching 0 to infinity. So here in the next line, you can see the two zeros. So in this part, we plug the limits. So if you plug this infinity, or you can set this as a high number variable, you can, so anything that is, or rather having a negative high exponent would be equal to 0. So if your limit is a high variable and it is a negative exponent, it will be equal to 0. Also, your sine bt or sine b times 0 or sine b times 0 is equivalent to 0. So that's why it is 0 already. So the one that is left is the b over s times the integration of e raised to negative st cosine bt dt approaching 0 to infinity. So another integration by parts. So we will set our u, du, dv, and v, which is equivalent to u is equals to cosine bt, and the derivative of cosine dt is negative b sine bt dt. So the dv is equivalent to e raised to negative st dt. So using integration, we will come up to b is equals to negative 1 over s e raised to negative st, which will lead to this equation when we plug in those variables. So b over s in close parentheses negative e raised to negative st cosine b